Okay, then I'm back here. Hi. So that's nice to see that the organizers are so behind everything and that they are checking everything. And it's a tough time schedule today. I saw that my time slot jumped around 20 minutes for and after. But I hope we are set. So let's relax a little bit together for the next 20 minutes or so. It's last talk of the day, and then you can all go grab something to eat and enjoy your evening. So my name is Thorsten. Thanks for the warm welcome. I'm a computer scientist and web engineer with a master's degree, currently working at a full stack developer. And the title, your own Vite plugin, that's as easy as 1, 2, 3D, suggests a little bit what I'm going to talk about in the next minutes. You can find me, of course, on various social media, but let's debrief a little bit. Maybe we want to make a plugin. We want to make something with 3D, GLTF files or stuff like that. And it would be very cool if it's not only for Vite, but maybe we can build something builder tool agnostic so that we can run it in other environments as well. So in the talk, we briefly talk about GLTF files. What are GLTF files? What we can use them for. Of course, you want to make them type safe in the end in order to make cool stuff with it. Then we want to build a Vite plugin on top of it with pre-processing. We want to generate some code that we can then use in our Vue project at the end. And like already said, it would be very cool if it's a plugin not only for Vue, but also for maybe other frameworks that are out, for example, Next or all the others that there are. And in order to do that, we want to bring the Vite and the Vue away and bring unplugin in play. And unplugin is something really cool I want to talk about in just a few seconds that helps plugins more or less create build tool agnostic plugins that then run in. Of course, it will deliver something for Vite so that you can use it in Vue and Next, or all the other bundle tools like ESBuild, Rollup, and what also they are called. So GLTF files, what are they? In 2015, just a little bit of historical recap, there was the first version of GLTF 1.0. It introduced a file format that we can deliver on the web to have 3D assets and whole scenes, cameras, lighting, and stuff like that. And in 2017, there was a second version of it, GLTF 2.0, that is used until today in three kind of exports. We can export GLTF separated files so that we have a GLTF file that is a JSON encoded meta file that holds together all the things that are happening in the scene, the camera, the nodes, and stuff like that. Then there can be binary encoded files with it that have, for example, the models and some textures like PNG image files in general. We can also use GLTF embedded. With this, you have only one GLTF file that is still JSON encoded, but all the other assets, the bin files, the textures, and so on, are base 64 encoded inside the URI as a data field. So the GLTF files get rather big, but you have everything in one single file. Also, in one single file, you could use the GLTF binary. Here you have a binary GLB file that is, of course, more or less optimized, but in it, the files are bundled. To be precise, there is still some JSON meta information in it and some also textures, and also you can have some bins that are all in one binary encoded file in the end. Okay, but let's look in one GLTF file to get a little bit a glimpse of how it works. So on the left side, you have a GLTF example, and on the right side, you have the object hierarchy. Here, this is something like the scene graph at runtime, but it represents how the objects are linked to each other. For example, at the top, we have the scenes, and it can have one scene, it can have multiple scenes. That is completely up to you. It's an array. And inside the scenes, you have some nodes. You can see them here. The nodes are the indices of the array of the nodes part. So here you can see the nodes, also an array. You can have many, many nodes. And on position 0, there is, of course, a node, and in the index 1, there is a node, index 2, there's a node, and so on, and they are linked. The same like the meshes are linked. So here we have a mesh number 4. So we have then look in the mesh array on the bottom, and on position, because it's an array number 4, there is the mesh that is linked to the node in our object graph. And this continues until the bottom. And on the bottom, you have some additional files like talked before. We have the buffers and the images. These are the URIs I talked about. In this example, I am linking external files. But like already said, you can also base 64 encode the things inside the GLTF file. Okay, how is this rendered? In the end, you have the GPU at the bottom of your computer. On top of the GPU, you then have WebGL. We all know WebGL. It's the thing that brings 3D in our browser. It's a very low-level API. It has direct GPU integration and is rather complex. So to abstract it a little bit, we use Vue.js. I think everyone here has already heard of Vue.js. It's a more high-level framework for WebGL. It helps you easier talk with the graphics card by abstracting WebGL commands. And on top of Vue.js, there are several libraries out there. In, for example, our case, for Vue and Nuxt, there's Stress.js. A shout out to Alvaro and his team at this point for this awesome library, but also in other frameworks, there are other things. For example, you can use Drei in React or Threlte in Svelte, and so on and so on. Okay, let's see how we can load a GLTF file in for Vue.js and also in Stress.js for our case. On the left side, you see how you can load a GLTF file in Vue, and on the right side, you have the abstraction, the helper possibilities from Tress. In this case, we must use CentOS in order to use GLTF files. It's an extension for Stress.js. And you see already some differences. On the right side, you have the Vue syntax we all know and we all love. And on the left side, we have pure JavaScript. But in the end, Tress is built on top of Vue.js, so it wraps and helps us using it. You see here, I am loading our island GLTF file on the left side and also our island GLTF file on the right side. And both get the scene object here. It's the first entry point in our scene graph. And from there on, we can go on, you can see it here, all the nodes from the scene graph before, so like the cameras, the assets, and so on and so on and so on. Okay, but loading it this way has some problems. It loads only at runtime. That's the first thing you're encountering. So no help in dev at all. You have no typings, no code completions. You can do not call maybe island.beach.rock1 or something like that. You have no safeguards. If you're mistyping your names, or maybe your files are missing at bundle time, you get no errors at all. The thing compiles, and only in the browser, the end user has some errors that you cannot catch at all at build or dev time. Also, there is a way you can get objects by name, like with this get object by name property on a node. But with this, you have a depth-first approach to find it in the scene graph. And worst case, you have to go through and walk through the whole graph in order to only find the last node that is the rock you want. So a very bad runtime when you get with this your nodes. Also, all your assets are always compiled. They are always public. So if you only use one of 5 models, all 5 models go into your build folder in the end. So how can we ensure making this a little bit better? With the type generation I talked about earlier. So we had developing the plugin I want to show you at the end some problems on the go. So at first, Vue.js is only, like already said, a runtime environment. You can use it in the browser. There are some extensions to it, like the Draco compression. I don't want to go too deep in it, but you can make really cool things with it, but all only in the browser. So our solution was we patch Vue.js. It's as easy as that. If you want to build something that your beloved framework or operating system is not giving you, just change it. This brings a little bit of complexity and another problem with it. Patching Vue.js in order to run it in the Node environment would mean that we need two versions of Vue. The one version of Vue.js we are using in node time to generate types, and a second version of Vue.js that the user in the end in his application or his or her application can use for really loading to runtime the models when after building the project. And these are the patch plugin from our side for the node and the original for the user. The solution for this is that we are using the Vue stdlib. It's more or less just a clone of the Vue.js example directory with an own Vue.js runtime, fully runtime bundled in it. So we can patch this and don't have to worry about what the user is making with his own Vue.js library. Okay, also something we had to consider on our way for this plugin was an API design we had to decide on. So what decision, what route do we want to go for the user end app? We could, for example, go the way, say that usability is the most important thing to us. For example, by prioritizing the usability, we could make something very easy like, okay, let's say you are loading the scene, right? And then you have the island scene. Just make a dot and you get auto-completion for all nodes that are in the root of island scene. In our example, island. After you have typed island, you can set a dot and get all the nodes that are in island. So here, beach. And on the beach, there are rock, 1, 2, 3, 4. Very easy, very straightforward, something we all know, we all are using on a daily basis, but it has some downsides. The first downside and the biggest downside is that we have to create this potentially very large object of the scene, the complete scene graph, in one single object and ship it. But the positive side, the user can really easy work with it. So a second approach would be we want to prioritize the bundle size. Because this object is quite large, we maybe want to only ship the things the user really is using. And this could be achieved by creating getter functions. And each getter function must be provided by the parent. So you get the thing from the other side. So we are not starting with the scene graph on its root. We are starting at the leaves. And the leaf is the rock. So we want to get the rock. And in order to get the rock, we must pass the parent. The parent is the beach, and so on. Of course, this is not very user-friendly, but we could potentially tree shake it. And then we have a good bundle size in the end. Or a third approach would be to combine it. We could crawl the user code. We could analyze the code and the project the user is creating, but don't get me started on this one. So the implementation was after deciding on the usability part. So we want to make something that the user can easily use. And we do not care about the bundle size too much because in the end, making the whole object is in comparison to the object itself and the bin files, even if they are Draco compressed, a very small proportion. So we are just taking this user approach and the bundle size is not to matter too much. We run Vue.js in our node environment and pipe the models into it. That's the first step we are doing in order to get the runtime objects. So we are not passing the GLTF files our own. We are letting Vue handle it. So we really get what Vue would also generate at runtime later in the browser. So it's very easy. We can work with that. And if the Vue.js has a breaking change or something like that, we also adapt to this on top because we do not have a second reality. We must ship also with new versions. After we have created this runtime object, we generate the types with it. And by that, we're taking the names of the children and linking them with the indices of the children inside the arrays. And then we use handlebars to generate the files we then want to use in the project. And here in the example, we had GLTF separated. So the first 4 black shown files are what the user has provided in the project, and only the second last files are what we are generating. We're generating the types, and we are generating the real code, the helper functions that the user can use in the project. How does this look like, you may ask? Let me show you by an example. I have the island example from before. On the left side, you can see the types file, and on the right side, you see the generated code that the user can then import and use. And you can see a little bit about the magic. The big object is here. Of course, in this example, we have a very small object, but trust me, this can get very fast, very large, thousands of lines, only to get the scene quite right. And we store only the indices of the children, like I said, in the arrays. So here you have 0, 0, 0, 0. Of course, it's an easy example because always it's a position 1 in the array. But later with real scenes, there are all kinds of numbers depending on the index of the array that is shown. And the typing is done down here with the get node. And you see we are getting groups with the first, the second, and the third function. And the last one is returning a mesh. So we are crawling the real type inside the generated object from Vue.js and pasting it in here so that when you are using the GLTF file typesafe in your code, you get the real type that the Vue.js is rendering out of the GLTF file. Okay, so we had some problems I showed you before. Now let's talk about the solutions we are providing with our approach. The first thing was that it only loads at runtime. Okay, we fixed that. We now have a patched Vue.js version. We can trigger in dev and in build time and have full control over it. So we have typings, we have code completion, we have safeguards on build, we get notified if a model is missing, or if someone in, for example, Blender changed the names of the nodes and we are not able to get maybe rock 001 because it's now stone 001. We get a type error and we get this on compile time. Also, we can make some calls inside the scene graph, and it's only going the direct way we want to go. No searching, no depth first, no other algorithms you could throw on it. All easy as that. Also, the models are now in the source assets folder, so we can version them, and only the models we are using get in the bundle directory at the end. So that's cool. That's awesome. Now we have a Vite plugin for Vue. Now let's make it bundle tool agnostic, or build tool agnostic to be precise. And we are using for this un.js unplugin. It's a unified plugin system for build tools. And like Alex would say, big shout out on this point, it's like jQuery for build tools. He said it yesterday to me and I was fascinated about this. So yeah, it's in the end, it is exactly that. You can build one plugin and then ship it to all kinds of build tools out there for Vite, for Rollup, Webpack, and what you want. You name it, and it is there. Of course, it is not 100% out of the box possible to do it because the bundles are different to each other. Not everything we have in Vite, we also have in Webpack or in ESBuild. And that is where our challenges began implementing this. The first thing we noticed was that the documentation is not always correct on un.js. I know we can contribute to it, and we all should contribute to open source software because it's very important. But just to have one example is this one, so that the, for example, load include is okay for everything except for the farm bundler. We don't know why, but it's a little bit of a mismatch. Something must be patched there. This is one of the challenges. You have to get behind of it because, of course, in the first iteration, you always trust the documentation. The next thing is that ESBuild does not allow us watching the files, or only allowing us watching files in separate build phases, not always. And this limits the watcher benefits because, of course, you want to have a watcher if you change your GLTF files, load new ones in, load some out. And this is not easy with the ESBuild, and this was also a limitation we came across. Also, the emit files does not work with every bundler the same because some does not return your generated file name after putting it in the assets. So the solution is that, yeah, they are built different. And our solution to it is that we just make a fixed file name for it and provide the file name. We hash our own, and we do not want that the bundler is hashing the file name itself. Of course, these are only 3 examples. There were other challenges as well, but it's like all software projects. There are difficulties you have to find, and you have to get over it. And also we had with the Yarn plugin. Okay, also just the last one, you have some problems finding if you are in dev or in build. That is very frustrating. It's not always in all possible. So sometimes you do not know if you're in build or in dev. Yeah, we have to work some way around it. It's a very hacky, it's not perfect at the moment, but we're working on it. And we want to contribute our solution in the end, that others have not the same struggles that we had. So all of this made our awesome new plugin. We also published it this day. At this point, a very, very big thanks to Andreas Fehm, one of my best mates. He programmed yesterday until late in the night to change the last, to fix the last bugs and made some new improvements to it. And I saw like 20 minutes ago, he already encountered some of the open issues we had opened this morning. But yeah, that is our plugin. You can go on it on GitHub. You can give it a star. You can try it out yourself. It is well documented. We hope so. You can contribute to it and play with it a little bit. And on the bottom, you also see which problems we have with the bundlers, like I told, because not everything is perfect yet. So how do you use, or why do you need it in the end? Of course, to all the nice things I talked already, the code completion, the build failure, the type safetiness, and in order to not lose your head in complex scenes. So for example, we are building a little demo, a proof of concept for a little in-game browser game that is fully, I'm sorry for that is fully, could I please? Okay. That is fully working in the browser without installations or stuff like that. And it is built with Vue.js and Tress. And also here, a big shout out to Andreas for helping and for doing this with me. I'm just building a little windmill here while we are waiting. And I'm talking about the complexity of this scene. Also, this little island has so many nodes that we had problems just by, okay, which tree is where? Okay, we need a second tree. We must rename the first tree. We must refactor it. And it is breaking every day in the end. So that's why we decided to make this plugin in order to also help our own lives. And also something like, yeah, okay, I have a windmill now. The wind turbine should rotate. Okay, it should not rotate this fast. But getting the wind turbine is something like, yeah, windmill.wind turbine. Perfect. I have the node. It's perfectly typed. I can then dot rotate x equals something on delta, and that's it. It's very, very easy and very cool to use. So the takeaway for this talk is in the end exactly the slide I showed at the beginning. We made a cool plugin. We used Unplugin to ship it to all kinds of build tools, and then now we can use it in all kind of project. We are using it in Vue because the little island game is made in Vue, but Next is also supported. Also, you can use it in Astro. Whatever you want, you call it. There it is. So thanks for listening to me. Here are all the neat links to the source codes and the licenses and all the stuff like that. Check it out, go there, give it a star, play with the game a little bit, contribute to the game. And just one last thing, because tomorrow Alvarez is giving a talk about post-processing, and I'm very hyped about this. We also have something here to highlight the build plates. And this is done with the old post-processing. So I hope we all are learning tomorrow something cool. And we can then fix the problem that in the night, the post-processing is gone. Thanks for your attention.
Splendid. Thank you. We do have a couple questions. To start with, how do you handle error reporting in Vite plugins?
It depends on the kind of errors. So so the errors that are from the Vite environment are thrown from Vite itself. We are not piping them, we are not touching them. The only errors we must raise ourselves is in our core, and the core is about the GLTF, type generation and all like this. And there is an unplugin hook where what you can use then to raise errors, and it is raised in whatever build tool there is at the end, and it raises Vite errors, of course, when you're in a Vite environment, but direct Vite errors we do not touch.
Awesome. Thank you. All right. Oops, I made it go away. What strategies do you use for testing Vite plugins? I feel like you kind of answered that with the first one, but could you go into more detail?
Yeah, I can try. So of course, we all should write tests, and we try to deliver the tests in the next days. But at the moment, we do not have any tests at all. It was a very short notice for ourselves to get this plugin up and running, to get it tested locally in the end in order to use it. But there are no tests, so very sorry, these are only coming.
All right. And how do you handle development versus production modes in plugins?
Yeah, that is something I talked about. It is not, there is no hook or no variable you can call in order to get, I'm in dev, I'm in build, I'm in production or something like that. So you can check out the code, of course. We made some workarounds by just checking if some variables are present, because some bundlers like ES build are putting special variables only in the dev mode. They are changing inside the dev mode, but they are there in the dev mode. So we can check on the existence, and then we know, okay, we might be in the dev, but maybe they change it in the future. So there should be something more reliable, but for the moment it is working. We tested it, so trust us, I think. But the code is open source, so check it out.